Welcome to a video on section 14.4, which is about solve trigonometric equations. So like most units, at the end of each unit, we want to solve an equation using the things that we've learned previously in that unit. Before we do that, we do want to talk about the difference between a trigonometric identity and a trigonometric equation. So here, this would be an identity. The reason why is because the left side equals the right side for any value of x. For example, say I presented you with something like this. This would be an identity because the left side and right side are always the same. If we were to FOIL the left side, so they're always just going to be the same, and so any value of x would always make that true. This, however, will be an equation because only a certain number of values can work for x. So not anything could work to make sin x equal to 1. So in 14.3, we're verifying identities. Here in 14.4, we're solving equations. However, we'll still wind up using the identities we learned in 14.3 to help us solve the examples we see below. So let's start with number 1. You're asked to solve 2 sin x minus root 3 equals 0. Now, like most equations, we want to isolate x. But how? Well, hopefully, if you said that we have to add root 3 to both sides, that's correct. Because that's how we're slowly going to get x by itself on the left-hand side. If you said divide by 2, you're correct again. Because again, we want to get rid of anything that's on the left side that's not x. Now the next thing we have to do is take the inverse sign of root 3 over 2. And remember what this means. What this means is that what angle will make sine theta equal to root 3 over 2. And also remember that this is going to be the y-coordinate on the unit circle. So if I go to my unit circle, I see that over here, the y value is root 3 over 2. I'll see the same thing over there. So the two values that make that work will be pi over 3 and 2 pi over 3. Now we do have a default range for inverse sine, but in this problem, we're asked to solve an interval from 0 to 2 pi. So starting at 0 and ending at 2 pi. So we want to go around the whole circle. So our answer is going to be pi over 3 as well as 2 pi over 3. Now for number 2, again same thing, we want to isolate x. So we'll subtract the 2, and of course divide the 3. Now, you're going to want to square root both sides, because right now we have tan x squared. Remember, tan squared x you have that. So you square root both sides, you have tan x equals plus or minus root 3. So x will be the inverse tan of root 3, and x will be the inverse tan of negative root 3. Now remember, tangent theta is y over x. So we want to locate where y over x equals root 3 or negative root 3. That would happen over here, because if you did y divided by x, you would get root 3. Also would happen right here, you get the same thing. It would happen right here, and of course it would happen right here. So the places will be x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Those will be the 4 locations where tangent could be root 3 or negative root 3. Okay, on to number 3. So again, you want to isolate x, but let me caution you. Don't divide by sine x. If you do, you'll lose a solution. And here's the reason why. Say I ask you to solve this equation. What would you say? Now, if you said to divide by x, and by the way, don't copy this down, this is wrong. If you divide both sides by x, you're going to get x equals 1, right? But this is the right way, so this is wrong. This is the right way to do it. You'd want to subtract x from both sides, then factor out an x. X equals 0 or 1. Notice how this gives us a whole story. This only gave us 1, the left side, but we wanted, 0 and 1. So I would not divide by sine x. Instead, what I would do is subtract by sine x. Or sorry, for sine x in this case. Then you factor. So sine x equals 0, or sine squared x minus 4 equals 0. If you keep going with the second equation, sine squared x equals 4, sine x equals plus or minus 2. Well, this would result in undefined. That's because nowhere can sine be 2 or negative 2 on the unit circle. Plus, we can't have a sine value greater than 1, because that would imply that the side opposite the angle will be greater than the hypotenuse, and of course, hypotenuse has to be the longest side in a right triangle. So we can't have that. Over here, x will equal inverse sine of 0. And where would sine be 0, or the y-coordinate be 0? At this location, and this location, which is 0 radians, and pi over 2 radians. Sorry, 0 radians and pi radians. So 0 and pi. Lastly, cosine squared x equals 4 minus 4 sine x. Again, what we're going to do is we'll move everything to one side, just like we did in number 3. Now, if we think about it, this is kind of like saying y squared minus 4 plus 4x equals 0. Could you solve that if I gave you that equation? You can't, because you need another equation. Can't solve unless we sub for one of the variables. So coming back here. So we know that cosine squared x plus sine squared x equals 1. And we're going to have to substitute for cosine squared because there's nothing that we can substitute for sine. So we're going to have to substitute for cosine squared. And cosine squared x equals 1 minus sine squared x. So I'm going to substitute and replace my cosine squared with 1 minus sine squared. If we move things around, or to combine like terms, actually just do that first. We have that. Then move everything to one side, so that way our leading term is positive. And then we're going to want to factor. Now this is going to be just like saying x squared minus 4x plus 3, which hopefully you know is x minus 1, x minus 3. So same thing here. Sine x minus 1, sine x minus 3. It's analogous to factoring a quadratic. So of course sine x will have to equal 1, or sine x will have to equal 3 to make this true. This will be undefined, because remember sine can't be larger than 1 or less than negative 1. Here, this will only happen at pi over 2. Because going back to the unit circle, that's where the y-coordinate's positive 1. And looks like we are all set over here. So this concludes the video, and we will do practice problems on this next time we meet as a class. Okay, goodbye.